seen that if you take a spherical glass ball and slice it, polish it, then you get a spherical mirror like a concave or a convex mirror. Now, the center of the spherical glass ball before we sliced it is the center of curvature, and this axis is the principal axis, Principal axis, that is the main axis. Now, let's throw some light rays on these mirrors and see what happens. Well, first, let's throw a light ray that is parallel to the principal axis. What happens? Well, you see, light travels in a straight line, and also it follows the law of reflection, which is the angle of incidence is equal to the angle of reflection. So, if this is the angle of incidence, this will be the normal and this will be the reflected ray. Well, so as we can see here, the normal passes through the C, which is the center of curvature, and the light ray reflects through this point. Okay, now let's throw another light ray that is parallel to the principal axis. Well, the same thing happens. So we see a pattern here. That means any ray that is parallel to the principal axis will pass through the focus, which is F. So if this is F, which is the principal focus, and this is the point P, which is the pole on the mirror, then the distance between P and F is the focal length. And this F lies exactly in between the center of curvature and the pole P. So, if this is a circle, then this will be the radius of curvature R. And as we can see here, this R will be equal to 2F, where F is the focal length. And even in the case of a convex mirror, the rays that are parallel to the principal axis will be reflected and pass through the point F. And if you draw a normal, that will pass through the point C. So what have we learned in this video? We have seen how the reflections are possible in spherical mirrors and how they follow the laws of reflection, and we have seen what happens when a light ray is parallel to the principal axis. So until next time, happy learning!